Now, we are all taking interest in growing crops, and first and foremost thing that a crop needs is nutrition, just like the man needs food to survive. So similarly, the plants do require what is called as nutrition, so that they can prepare their own food. Unlike animals, plants can manufacture their own food and consume it also later. So the process of manufacturing the food is called photosynthesis in plants, and the process of consuming is by way of respiration, just like in the case of human beings. In the case of human beings, there is a digestive system. In plants, again, it is the same concept where the carbohydrate is broken down and used as energy by way of respiration using mitochondria. So now let us go further. So as I said, what is this nutrition? Food of all of the plants composed of many chemical elements. What is that? Essential plant nutrients, the carbon, hydrogen, oxygen. These are available from the nature. And NPK, that is nitrogen, phosphorus and potash, calcium, magnesium, sulfur, manganese, molybdenum, copper, boron, zinc, iron, chlorine. Like this, there are mainly 16 different elements. They are classified as macro and micronutrients. The macronutrients are basically NPK, nitrogen, phosphorus, and potash. And the all other nutrients or chemical elements are called as micronutrients. So basically in nature, all these things are available by the base rock material or the soil, and something by air like carbon dioxide, oxygen, and sometimes nitrogen also. That is from the air. And water that we are going to use for irrigation can also have some dissolved salts. It can be magnesium, and it can be manganese, it can be calcium components, even nitrogen. So like this, different nutrients can be also there in water, but in a smaller quantity. Afterwards, we go in for applying the organic manure, that is the farm waste or animal waste, properly composted, and that will supply a smaller quantity of nutrients, but very essential. We will see that later. Apart from that, this fertilizers are there, which are manufactured in industries which are having higher quantity of nutrients, NPK or other micronutrients. So entire things are in two categories, either cations or anions. Cations are those which are positively charged. Basically, they can be magnesium, calcium, manganese, like that. Other negatively charged anions are acidic in nature. So now the quantum. In case of manure, that is organic matter, the NPK component is less than 2% or somewhere hovering around 2%. Micronutrients are in traces. However, they are there. So copiously applying farmyard manure is very essential in case of farming. Today, we have also taken more interest in what is called as organic farming, wherein we try to supply all the nutrients, major as well as minor, by organic manure only, that is animal waste and plant waste. So we avoid basically the fertilizers in case of organic farming. However, micronutrients are sometimes used as per the need. Then utilization. it has to be in any soluble form. If these elements or the compounds or the fertilizers are becoming insoluble by precipitation, by some chemical reaction, then it cannot be absorbed by the plant. It has to be in soluble form. Now, let us see what are the important uses or utility of these nutrients. The major nutrients, basically the first one is nitrogen, which is first among all, very important, and it is consumed on a larger quantity. And it also very easily leaches because it being highly soluble in water. Leaches means it will get dissolved in water and goes away from the plant root zone, either to deeper layers of soil or away from the soil, away from the plant to in the flowing water. So this nitrogen, which is very important, is required for the formation of proteins, and it is the most important nutrient. It is also part of chlorophyll, which is a receptor of light energy. So the plants are going to manufacture their food, that is carbohydrate basically, using the chlorophyll, using the light, sunlight or any other artificial light that we may provide, and they manufacture the carbohydrate. The carbon source can be from carbon dioxide from the air, and hydrogen and oxygen from the water. So the air itself contains nearly 78% nitrogen in the nature. But however, plants cannot use this air directly. With the only exception of legumes, the plants which are belonging to leguminaceae, they are called as legumes, and they can use nitrogen from the air using a symbiotic bacteria called as rhizobium. This rhizobium stays in the soil on the roots of these legumes. Legumes are basically the pulses, the dal, all kinds of dal or the pulses. So there these rhizobiums will survive, and then that is their place or the home, and there is a symbiotic relationship with the plant, and these rhizobiums will absorb the nitrogen and fix it in the nodules, root nodules, later on which goes into the soil. So this helps in reducing nitrogen requirement, that is external application. So this nitrogen encourages vegetative growth, imparts very dark green color to the leaves, so that good photosynthesis can take place, so that chlorophyll content is kept higher. This nitrogen regulates utilization of the next two important nutrients, that is phosphorus and potash. Phosphorus is represented by alphabet P, and potash is represented by the alphabet K, because K is kalium. So that K comes from that word. So P and K, NPK. So again, nitrogen helps for higher yield. Essentially, it is very important. In absence of nitrogen, higher yields cannot be there. When nitrogen is applied, it increases the succulency in salad crops, basically all kinds of salad crops, leafy crops, fodder crops, which are used for animal fodder, and even in vegetables. They become juicy and succulent. And this nitrogen is basically being component of protein. When it is applied, it increases the protein content and size of the fruits or the grains in case of field crops. What happens if this nitrogen is in surplus? See, we know the farmers use basically NPK. Out of that, maximum application is done using urea, and which is a source of nitrogen. And urea has got about 44 to 46% of nitrogen. So what happens if there is a surplus application of nitrogen? It will always encourage vegetative growth, delays ripening of the fruit because vegetative phase is continuing, Crop looks more dark green, very soft and sappy, that means juicy, increases disease attack from bacteria, fungi. That means there is lower resistance because of the very soft nature of the plant tissue. In case of leafy and cereals or the monocots, the stem becomes long and weak, and the crop largest. Largest means it will fall down. Stem becomes weak and long, so the crop will become fall down. So this can happen even in case of our leafy vegetables. If we are cultivating them with higher nitrogen or even in shade, less light. So if the nitrogen is in excess, then crop quality deteriorates, fruits may rot early, they may attract diseases early. Likewise, vegetables also cannot be preserved for long, either open or even in refrigerator. So nitrogen has to be applied in the correct quantity, not higher, not lesser. It also delays reproductive phase, that means vegetative phase will be going on. Reproductive phase, it will not enter. Yeah, which one? The plant. So surplus nitrogen is not advisable. Now let us see what happens if there is nitrogen is deficient. See, generally farmers keep throwing urea, so always the possibility is that nitrogen is going to be higher. However, if the farmer does other mistakes, like you see irrigating very heavily after application of this nitrogenous fertilizer, it can leach and run away from the field or the crop. So under that circumstances, either it will go down into deeper strata of the soil or away from the plant along with the water. So there can be such situation, and it can create a deficiency or lower application of nitrogen. Then what happens? Plant will look yellowish or light green, stunted, that means growth will not be there, and leaf drop prematurely happens. That means very early stage, without having the going through the full life of the leaf, it will drop off. So that is a mechanism of the plant to adjust by dropping the leaves. In the remaining few leaves, the available nitrogen is used so that photosynthesis can take place. It's a defense mechanism. So leaf drop will happen prematurely. However, that will affect the yield for us. So fruits ripe prematurely because you see there is no strength for the plant to survive with the required nitrogen. So there is difficulty in metabolism. So what happens? The fruits become ripe prematurely, and that is why it leads to poor yield. The size of the fruit will be smaller. If it is a seed, it will become very weak, and like that, yield will be lesser. Then, as I said, it delays the reproductive phase. There can be flower drop because available nutrition will be divided among a few flowers that are retained. So, plant tries to manage its future activity, that is reproduction, by way of dropping the flowers. Similarly, root growth is also severely affected. So overall, the plant becomes weak. Let us take the second one. Second one is called phosphorus. It is also very important nutrient after nitrogen. But in the absence of phosphorus, even the nitrogen will not be used properly. So it is second important nutrient. It takes active part in metabolism. What is metabolism? It is conversion of food into energy or energy into food. When it becomes energy into food, when the food is consumed and it is broken down to form energy, it becomes energy to food. In case of plant, what happens? They use the energy from the sunlight and then they manufacture. So energy to food will be the case in case of plants. However, when they do respiration, they will also break down the carbohydrates manufactured, and thereby energy is created. ATP, ADP reactions are there. So adenosine triphosphate to diphosphate, diphosphate, triphosphate is the action in respiration and in case of food manufacture. So this phosphorus is an important constituent of major enzymes. So the enzymes are going to be active in ensuring the metabolism to happen. So without phosphorus, the metabolism will be affected. It is a structural component of cell membrane, chloroplast and mitochondria. Cell membrane helps in selective permeability of the nutrients and water, gives strength to the cell as well as plant, protects the plant from disease attack. Chloroplasts are those organelles which are used for storing the chlorophyll, thereby they are the place factories of production of carbohydrate or the starch by the plants. Mitochondria is the other way around. It is a respiratory center, and there the food is broken down, the carbohydrate is broken down, and energy is given to the plant to work. Let us see what are the functions. It stimulates, phosphorus stimulates root growth in seedling stage itself. Also later on also, but even in seedling stage. It hastens leaf development, encourages greater growth of shoot and roots. What are the functions? Enhances development of reproductive parts. What are the reproductive parts in plant? Basically the flower, androecium, gynoecium, all those things are there. So it enhances the development of reproductive parts. It also gives resistance from the diseases. Resistance from the diseases. So if proper phosphorus is not there, then leaves will easily get affected by fungus or the bacteria. It prevents lodging due to stronger cell wall, gives strength to the stem. So lodging will not be. Lodging is becoming lean and lanky and falling down. The plant becomes lean and lanky and it falls down. It cannot stand erect. Then it stimulates flowering. Proper phosphorus means it stimulates flowering, fruit setting, seed formation, and root development. Especially root development, especially in case of root crops. Whatever is grown under the ground, that those root crops, it will be helpful in formation of these roots or root development. In case of legumes or pulses, it induces nodule formation in the root zone or on the roots and by the and rhizobial activity or by the rhizobial activity. Rhizobium is bacteria is present in the root. It helps in fixing the nitrogen more and more from the air. This phosphorus influences cell division and formation of fats and albumin. Albumin is the protein. Fats are related with oil. Now what happens if it is surplus? Surplus means there will be profuse root growth. See here, root growth will be profuse, not the shoot. Especially lateral and fibrous rootlets, not the prime mother root. Lateral roots will be developed or fibrous roots will be developed more. It may cause trace elements like iron and zinc deficiency. Okay, because it becomes soil can become more acidic and the deficiency of iron and zinc can happen. Deficiency leads to root and shoot growth restricted. So the shoot and root growth will be restricted and plant will become thin and spindly. That is what we said, lodging will happen. Leaves become dull grayish green. See, when nitrogen was in a good quantity, it will become dark green. Here, deficiency, again, it will create just like shortage of nitrogen and there will be grayish green, dull green appearance of the leaves. Then leads to slow growth because chlorophyll is missing. It is dull green means what? Chlorophyll is missing. So thereby growth is slow and yield also will be slow. So further deficiency, premature leaf will be shedding, delay in flowering and fruiting, stunted growth or lesser growth, even under excess of nitrogen and potassium. You see here the synergic reaction. If nitrogen, potassium is there properly, but phosphorus is not there, then there will be no activity much, there will be stunted growth. So, in the right combination, nitrogen, phosphorus and potassium should be given to the plants. That is the management. And when it is shortage, phosphorus is short, then premature ripening of the crop happens, yield will be lesser. In case of crop like potato tubers, it can show rusty brown lesions on the potato tubers. Let us come to the third important element, that is potassium. In other words, it is called as kalium. It is a third important nutrient. It acts as a chemical traffic policeman. Means what? Sodium potassium pump is essentially the one which permits entry of nutrients into the cell. So, if potassium is lacking, then chemical uptake can be hindered. So, this potassium boosts root development, root booster, and enhances stalk strength. Means the stem will become stronger. Helps in food formation, that is carbohydrate, sugar, and starch are the carbohydrates. So, this potassium, if it is there in right quantity, sugar and starch are manufactured by the plant. And it also helps in transportation, protein building, breathing regulator, water holding in the cell, and it also enhances disease resistance. So again, potassium works only under proper quantity of availability of nitrogen and phosphorus. All these three NPKs are all interdependent. If there is one is less, the other one will not perform properly. So NPK balance is very essential in case of nutrition management. What are the functions of potassium? Essential element of chlorophyll development for photosynthesis. Important nutrient in case of potatoes, root crops, and sugarcane. See, because root crops, again, there is high quantity of starch is manufactured and stored in potato. Although it is a stem, underground stem, there also a lot of starch is stored in case of potato. Sugarcane, it is sugar, which is also a carbohydrate. It also demands potassium. Improves health and vigor of plant. Tolerates adverse climates like drought. Potassium, if it is in the correct quantity, it helps to tide over adverse climatic conditions like drought. So as I said, it prevents lodging, and that means stem will become stronger. Cell walls are going to be stronger. It also gives disease resistance. Functions. Improves quality of fruit and vegetables. Exerts balancing effect on NLP, as I said. It's an enzyme activator. Enzymes are very important for metabolism, whether it is human or plant. So this will activate the enzymes. Increases plumpness, that means it becomes juicy and big, and boldness of seeds and grains in case of legumes, all kinds of pulses. Improves water balance in the cell, promotes metabolism, that is formation of carbohydrate or breaking down of carbohydrate, increases production of the carbohydrate. Deficiency leads to stunted growth, short interrods, thereby it looks like a bushy appearance. It is bushy, not busy. Bushy appearance. Chlorosis is seen. What is chlorosis? Totally yellowing of the leaf. That is seen. And in some cases, leaf scorch is seen in fruit trees basically. And in some case of cotton and other plants also it can be seen. So leaves are going to have leaf scorching, means burning. So they look red as if they are burnt. Then dieback of tips will happen. The tips, apical bud, there will be dieback in case of potassium, because there is no nutrient supply. Older leaves show symptoms earlier, means it is mobile. From old leaves, the potassium is taken up to the younger leaves for the plants to continue their growth. So what happens? Older leaves will show symptoms earlier. Reduced rate of photosynthesis observed naturally, because interaction between nitrogen and phosphorus is not going to be there, because there is lesser potassium. So no photosynthesis or lesser photosynthesis will happen. Let us come to micronutrients. We all know, as human beings, we all consume these mineral tablets, vitamin mineral tablets we consume. These mineral tablets basically means they are micronutrients. Similarly, in case of plants, they also, because living beings, cells are there like animals or a human being, they also have having cells. So they also require these micronutrients. So let us see one by one. First one is the calcium, and it is generally visible as calcium pectate, important constituent of the cell wall, required for cell division. So here the calcium imparts strength to the cell, thereby again lodging will not happen. The plant will not fall down. It promotes root growth, elongation of the cells, and also cell division. So that means it helps for the growth, prevents lodging as I explained. Helps in translocating sugars. Translocation means what? Movement of the sugars, carbohydrates, from where? From the leaf, where it is manufactured, to other parts of the plant. Source and sink relationship will be there. Source is leaf, where the sugar is manufactured. Sink will be generally fruit or the roots in case of root crops. So source to sink, movement will be there, and that movement is called translocation of sugars. So micronutrient calcium enhances nodule formation in case of nodules of legumes. Nitrogen fixation, it helps. Neutralizes organic acids. Calcium being alkaline in nature, having higher pH, it neutralizes organic acids, which can become toxic at higher quantity. Calcium also activates enzymes, enhances disease resistance, because cell wall is going to be a strong, penetration of fungus or the bacteria becomes difficult. That is how the disease resistance is imparted or given. When calcium is applied in correct quantity in soil by any method, it is going to correct the soil pH or soil acidity. So if if from low to normal, if you are moving, in case of soil pH or the acidity, then uptake of iron, boron, zinc, copper, manganese will be better. Otherwise, under very acid conditions, that can be blocked also. Structure of soil pH improves and soil aeration also improves. That is why we apply calcium salts like gypsum, calcium sulfate in case of alkaline soils. Deficiency of calcium, what happens? Younger leaf of the terminal bud. In the bud, the younger leaf dies. It's called dieback of tips and margins. The tip, first the leaf edge will die, and ultimately the tip or the leaf, small young buds will die. So dieback will happen. Normal growth is arrested. Roots become short, stubby, and brown. See, these all, especially in micronutrients, these symptoms are explained based on very good studies, maybe sand culture studies. All these symptoms may not be there in case in your farm or in your plant. So identifying this situation becomes extremely difficult. Crop to crop, the symptoms are different. So this part of the understanding or diagnosis is a very difficult activity. It requires greater depth and knowledge in understanding the plant life. So this is wrong. Actually, it increases the pH in the soil, not acidity as such. Acidity content we can say. So it increases the pH in the soil, that is more appropriate. So it can become acidic to neutral, thereby making it making available so many elements, micronutrients basically. So deficiency, yeah, correct. Deficiency will increase the acidity in soil, correct. So if calcium is absent or reduced, then it increases acidity in the soil. So availability of certain nutrients become difficult. If there is a deficiency of calcium, flower and fruits will drop. Next is magnesium, next important micronutrient. The essential constituent of chlorophyll, imparts dark green color to leaves, needed by the plants for the formations of oil and fats. So in case of oil crops, like sunflower, etc., sunflower mustard, etc., magnesium content becomes very important. It regulates the uptake of nitrogen and phosphorus, increases resistance to drought and diseases, requires for the production of carbohydrates, proteins, fats, vitamins, which means basically everything, and helps in translocation or transportation of the produce to the sink where it has to go and reach. That is leaf to the fruit or root. Deficiency of magnesium, what happens is yellowing of older leaves. That means it is mobile, it moves away from the older leaves to the younger leaves. So if older leaves will show yellowing first. That yellowing is called as chlorosis. Acute deficiency leads to defoliation in any case. Because plant has to survive, it drops off leaves, thereby younger leaves can survive. That is the idea. Symptoms are observed in older leaves, as I said. Chlorosis with green veins. You see, chlorosis is yellowing. The veins in the leaf remain green. The other area, other than the veins in the leaf, becomes yellow. That is called as chlorosis with green veins. Next is sulfur, which is one of the important. This is going to create acidity in the soil. Part of amino acids, which are components of the protein. So the naturally the pulses would look into this because they are all protein-based crops, like our beans, different types of beans, soya bean or French bean, the field beans, all these things. So it is again important nutrient in case of oil seeds crop, cruciferous crop, which are all there, mustard, radish, turnip, all these things are cruciferous crops. It is also important case nutrient in case of sugar cane, and as I said, in case of pulses because they are rich in protein. Functions are, it helps in chlorophyll formation, promotes nodule formation in legumes, hastens root growth and stimulates seed formation. So, sulfur is a very important component, nutrient. What happens if the sulfur is deficient? The young leaves turn yellow. You see, not older leaves. Younger leaves will turn yellow. Root and stem becomes long or elongated. Then lodging will happen. Isn't it? So this is acidic chemical. So unlike calcium, what happens? Root and stem will become long. In case of calcium, alkaline chemical. So there what happens? The stem will become stronger. It will not lodge. Here it is ulta. In case of fruit trees, fruits will become light green, misshaped or wrong, abnormally shaped, thick-skinned and less juicy. So what happens? Fruit loses its quality. Older foliage turn orange or red and may get shed, that means drop. So the chlorophyll will be again absent, so it will turn into either orange or red. So these symptoms also are not very seriously going to be the same in case of all the crops. So we have to be cautious. We can't say this is the only symptom. So there is manganese, which is a very important micronutrient, essential in chlorophyll and for formation of oils and fats. So manganese influences uptake and utilization of other nutrients. So micronutrients basically what they do, they are acting at enzyme level, protein level, like that. So if they are absent or less in quantity, then entire physiology gets affected. So this influences uptake and utilization of other nutrients, basically main NPK. So manganese is also essential for photosynthesis, nitrogen metabolism and respiration. Means it is very important because it is for formation of food and also for breakdown and giving the or supplying the energy to the plant. So both are there. So it is going to be very essential, important element. Case of deficiency, there will be intravenous fluorosis, as we said earlier. Here also, between the veins in the leaf, there will be yellowing and veins will remain green. Symptoms are first visible on the younger leaves. Okay, because that means it is not mobile from older leaves to the younger leaves. So that being the case, deficiency will lead to younger leaves becoming symptomatic. See, next important element is boron. It helps in development and differentiation of tissue and carbohydrate metabolism and translocation of sugars. So this is also very important chemical, and generally boron and calcium go hand in hand together. So whenever you are applying boron, also apply calcium. Don't apply only boron or calcium. Both should go together. This boron helps in root development, flower and pollen grain formation. So in absence of boron or the lesser quantity of boron, what happens is the pollen will be grain will be affected, growth will be affected, dehiscence or bursting will be affected. Thereby, the sterility is created, and there will be no fruit formation. Retarded growth by deficiency, leaves turn yellow or red. So this is one indication. So as I said, pollen sterility will happen and malfunction of the reproductive organs, that is flower, male androecium, female gynoecium, etc. They will all become malformed. Thereby, you can't expect them to normally produce the fruit. So now let us move to something else, that is soil organic matter. So in case of nutritional management of horticulture crops or even field crops, organic matter is very essential. So generally what happens, organic matter is available in less quantity today in the farms because there is less of animal husbandry activity, and the farmers are also not taking more interest in manufacturing or producing organic matter. So thereby there is shortage of organic matter. Recently, some of you might have heard or read in newspaper that Saudi Arabia imported lot of cow dung manure from India because they are also trying to do some cultivation or horticulture under polycultivation or protected cultivation at very high temperatures of 45 to 50 degrees there in the deserts. So this organic matter basically helps in forming humus and humic acid. It is the source of humic acid. Flora and fauna of soil improves. Flora and fauna means the animal and the fungus, bacteria, which are helpful for the life of the plant, they are all going to improve when there is organic matter. Activates and helps, helpful bacteria. It activates organic matter, the helpful bacteria like azotobacteria, which is again nitrogen fixing, rhizobium, nitrogen fixing, phosphorus soluble bacteria. Mycorrhiza is a fungus which helps in greater absorption of the nutrient by extending the root surface into this mycorrhiza's body. So this organic matter further improves soil aeration, earthworm activity. So soil aeration, if it increases, the roots can breathe better, thereby they can absorb, or uptake of the nutrient is better. So it helps the plant to grow better. Even if the nutrients are there in the soil, if there is a poor aeration, roots are not in healthy condition, then uptake will not happen. Now let us see the fertilizer proper. See, because these organic manures are having very little quantity of nutrients. Generally, these are of the range of about 2–2.5%, whereas we require much higher quantity of the nutrients, different elements what we have discussed all this time. So let us see, then we have to support the plant with fertilizers, artificial fertilizer manufactured in the factory. So there are different types of fertilizers. Let us say nitrogenous fertilizers, those fertilizers which supply only nitrogen, only nitrogen. They are ammonium sulfate, urea, calcium ammonium nitrate, and calcium nitrate. This calcium nitrate is not easily available because it is in a very pure conditions. It is an explosive. So that being the case, availability is always restricted. Other nitrogen fertilizers are available. So next is phosphorus based fertilizers, single superphosphate, double superphosphate, triple superphosphate, bone meal, rock phosphate, diammonium phosphate. So these are all different types of fertilizers which will provide phosphorus to the plants from the external source. Then regarding potassium, generally it is muriate of potash, it is potassium chloride. So it will supply not only potassium but chloride also. KCl is the formula. Then somebody can prefer to use the potassium sulfate. By using potassium sulfate, you are supplying not only potassium but sulfur also. So whenever you think you want to apply, make it acidic, then you can go in for potassium sulfate. So that helps in supplying of the sulfur also. Then there are complex fertilizers. They are generally called as NPA. So this whatever I said next tells how much, what percentage of NPK are there. 15 all means nitrogen 15, phosphorus 15, potassium 15 percentage. That is percentage. 19 means 19% N, P, and K. So likewise, there can be other combinations like 22 nitrogen, 22 phosphorus, 11 potassium. So like that, it can be other combinations. Other nitrogen complex fertilizers are like diammonium phosphate, where there is 21% of nitrogen and 46% of phosphorus. Here I have given you some nutrient composition of different fertilizers. Ammonium sulfate has got 21% of nitrogen and nothing else. Sulfur will be there. Yes. Urea is having 44 to 46% of nitrogen. Calcium ammonium nitrate is 25% of nitrogen, which can be useful whenever there is acidity or when there is heavy sodium problems or black soils, cotton soils, etc. We can use calcium ammonium nitrate. It will balance the acidity of the soil. Then phosphatic fertilizer, single superphosphate with 16%, double superphosphate with 30%, triple superphosphate with 45% are available as phosphatic fertilizers. Then under the phosphatic, natural fertilizer is called as rock phosphate. It has got about 24% of phosphorus. And mostly it will be non-soluble. When you apply to the soil, you should also have copiously given organic matter. Thereby, phosphorus soluble bacteria is made available, which releases necessary acidity and converts the non-soluble phosphate into soluble phosphate, and thereby the plant can absorb it. Then organic matter source, you can take even bone meal. It has got a very high phosphorus content, like 20%. Then among potassium fertilizers, we have potassium chloride, muriate of potash. 60% of potassium is supplied by the potassium chloride or muriate of potash. And in case of potassium sulfate, it is 50% because there is sulfur radical that is present. So it is slightly 10% lesser than potassium chloride. However, it will give sulfate or sulfur, so one can choose that. It can be even in case of alkaline soils or the pH is nearer to 7 or higher than the 7, then this potassium sulfate can be helpful. And let us see certain other things in the nutritional management, how this fertilizer is applied. So fertilizer is generally applied in 2 stages. First we call basal dose. Whenever you are putting the plant first time or sowing the seed, you are going to put some fertilizers as basal dose. They will be generally half nitrogen, full phosphorus and full potassium are supplied because phosphorus and potassium are not translocated or moved in case of soil very easily. However, nitrogen is highly mobile. So we give all the phosphorus and potash, and nitrogen is given half at that time, half later on when the growth is really taking place. So then there is the top up. The remaining 50% of the nitrogen is given after about 40-45 days, depending upon type of the crop. That will be only nitrogen, and that is called as top up fertilizer. Nitrogen is fertilizer. Then where do you place this fertilizer? It has to be placed in absorption zone, not somewhere else, or the root zone. So the root zone, if you don't keep, then chances of fertilizer getting wasted will be higher. So in case of tree crops, the absorption zone is at the end of the canopy. If the tree is standing like an umbrella, at the end of the umbrella where the water drips, that place, nearer to that place, is the absorption zone. In case of small crops, it will be very nearby. In case of tall trees, year after year, they keep moving their absorption zone. So there only you have to apply the fertilizer. Then there are acidic fertilizers to be used in alkaline soils like ammonium sulfate, ammonium nitrate, or other ammonium fertilizers, because ammonia is basically acidic. And in case of alkaline soils, it is the other way around. Acidic fertilizer should be used. We can also do foliar application or leaf spray of these fertilizers. Thereby, lesser quantity is used, and direct application will reach into the leaf, and complaints like soil reaction, high pH or low pH, will not be affecting the process or the application if you are using spray. So when you are having trouble in making available the elements from the soil, foliar application is the answer. We can also use liquid fertilizers, totally soluble, in drip irrigation, or it is called as fertigation. So thereby you save labor, and the fertilizer is made available to the root zone where the plant is there. Then we can even use aerial spray using drones. Then in that case, the fertilizer should be totally soluble type, and we can just take it up 10 liters, 10 liters, 10 liters, and spray on the leaf. Large plantations like tea, coffee, or coffee slightly difficult because trees will be there. Tea more easier, and likewise if you are having mango gardens, any other fruit tree crops, you can use and spray through drones. You should also watch pH and EC. pH is the acid content of the soil, and EC is electrical conductivity of the soil. EC speaks basically of higher sodium if it is high, and lower anions. So now pH should be around 7, maybe 6.5 to 7.2, something like that. It should be better. It should be on acidic side, not on alkaline side. So 7 and below is good. In case of EC is electrical conductivity, it speaks about the sodium. It has to be around less than 1 in case of irrigation water, and less than 2 in case of soil sample. Soil amendments like gypsum, sulfur are added in the alkaline soils, so that proper acidity is maintained, and so whatever fertilizer we apply, that will not be locked by the chemistry of the soil, and it will be available for the plant to use. Then for each crop, the university generally gives a recommended dose. You have to use the same dose, or at least have the knowledge of that dose. Otherwise, you will be applying excess of NPK or any micronutrient. Proper irrigation and application is important. After giving the fertilizers, you should moderately irrigate. If you irrigate too much, then it will be leached, it will be sent away from the plant. So this completes the slides show, and we'll go for the questions. Any participants having some questions? This is a very large topic, big topic. So I've done some justice given the time. In fact, I've taken more time also. However, let us take some questions. And people who are otherwise interested later on can also send their queries to me on my contact.
Thank you, Mr. Anil Patil, for a very detailed presentation. I'll now take up some questions. Okay, so the first question is, in your experience, do most farmers manage nutrition well in horticulture crops?
That is the question.
Yes.
Yeah, nutrition management, you see, it is very complex in horticulture crops, or more complex in horticulture crops compared to the field crops. Field crops means basically grains and to some extent some field crop pulses. Because in case of horticulture crops, the yield per unit area is very high. If the yield has to be high, then nutrition supply has to be higher. And nutrition supplied also means proper uptake. So if there is a bad management practices or there is no knowledge, then even if you apply the nutrients, it will not be taken up, it will be wasted, it gets locked up, it may get precipitated and becomes insoluble because of soil chemistry. Under that circumstances, even if you put fertilizers and it will be a loss. So that is one thing. Second thing is the soil pH and electrical conductivity or the sodium content, etc., also has to be understood. So depending upon the soil, you will have different types of problems. In case of acidic soils, you will have some problem. In case of black soils or saline soils or alkaline soils or khara soils, as they call in Hindi, it will pose some other problems. Some of them we have discussed in macronutrient studies. So you should have thorough knowledge, and then only you can be successful. Ad hoc knowledge is not at all useful, especially in horticulture crops.
Okay. Mr. Anil, can you please stop sharing the screen and on your camera? Yeah. You can click on stop sharing.
Oh, stop sharing. Yeah. Yes.
Stop. Yeah.
Okay.
Yeah. Okay. Yeah. Okay. So I think you did not on the camera. Yeah. Now I can see. Thank you. Okay. Next question is, what are some profitable horticulture projects that you can suggest for farmers in southern India?
Yeah, is suggesting profitable crops depends upon various factors. That is location of farm, at what altitude it is located, and then what is the weather condition, and what is the soil behavior, red soil or black soil, etc. Based on that, different crops have to be suggested. So study of soil and study of irrigation water, study of altitude of the place, and study of the slope of the soil or the field. All these things have to be given. Then we can suggest the crops. Because for black soils or alkaline soils, the crops are different, which can tolerate salinity. In case of acidic soils of Malnad, it will be different. So probably you will be knowing in your area what types of crops they are growing. That gives a very good indication for you what crops that can be cultivated in your area.
Okay. And the next question is, can you describe some successful projects you have set up in recent years?
If I have to take up open cultivation, I worked for about 3 years in near Patna in cultivation of lychee as well as mango. In Karnataka, I worked on banana, coconut, mango, areca, and papaya. These crops worked in Karnataka, and sometimes a little bit of Safed mostly in Andhra, and aloe vera in case of Tamil Nadu. These are the crops, and yeah, that I think is the major crop sector.
Okay. And now we have the last question. What are the consultancy service you provide farmers and agro entrepreneurs?
We generally provide complete 360 degrees help. That is starting from even identification of the farm or the soil studies, water studies, borewell water study, canal water study, and then after that the soil profile, that is what is there underneath this earth for 1 meter or 2 meter we have to study, and then we have to study the elevation and then give suggestions. Then we have to recommend a proper modification into the soil. It may be drainage, it may be treatment of the soil. Okay, then irrigation systems, what they have to adopt, whether it is open soil flooding type or sprinkler or drip, whether it is going to be only water in case of drip, or you go for fertigation, that is soluble fertilizers are supplied in the drip lines. And then we also give a protected cultivation, that is polyhouse cultivations, in that general Indian type of polyhouses, as well as modern retractable polyhouses, which are of high value investment, and viability study, because whenever the money that you are going to put is going to increase higher and higher, then viability studies we conduct. So we help them to prepare DPR, that is a detailed project report, which is useful for the farmer to understand what happens to him or his investment, as well as for the bankers who has to understand what is the cash flow, whether he can repay, whether the surplus comes, in which year the surplus will come, what is the annual income and cost and benefit. All these things are part of the DPR. We also help the farmers to approach the bank, what is called a loan syndication, and we discuss with the bankers, explain to them and convince them that this is a viable project, and help the farmer to get the loans. Then once the implementation will come, how to plant the trees, which varieties, where it is available, planting material, where the cost is lesser, all these things we try to help the farmer. And once he plants, then we also make fortnightly, monthly visits, and then tell them what is going wrong, what is going right. Thereby, successful crop cultivation will happen. Once crop comes to harvesting stage, then we can also help the farmer how to market it, where to market, what are the methodologies they should adopt, so that they get better price. So almost 360-degree support we are giving to different types of horticulture crops all over India.
Okay. Okay, Mr. Anil, I don't see any further questions from our participants. So now we have come to end of question round. On behalf of agricultureinformation.com, we like to thank you for a very detailed presentation and answering all the questions. And we also like to thank all the participants for joining this meeting. The meeting will now be closed.
Thank you.
And I shared your contact email and number with our participants. So they can reach out to you directly.
Specific questions they can ask. No issue.
Yeah. Okay. Yeah.
Thank you.
Thank you.